In this video, we'll approximate the sum as n goes from 1 to infinity of 1 over n squared. So 1 over n squared is less than 1 over, so let's see, n squared is greater than n squared minus 1, so 1 over n squared, the reciprocal is less than 1 over n squared minus 1. And it's less than n squared minus n, and we have this less than 1 over n squared plus n. So n squared plus n is greater than n squared, and n squared is greater than n squared minus n, so it works the opposite way. So the sum, as n goes from 1 to infinity, 1 over n squared. Well, let's just take a couple of terms out. So this would be 1 plus 1/4. That'd be 2 squared plus sum, as n goes from 3 to infinity of 1 over n squared. And we can use this fact. So the sum, as n goes from 3 to infinity, of 1 over n squared is less than the sum, as n goes from 3 to infinity, of 1 over n squared minus n, and is greater than the sum, as n goes from 3 to infinity, of 1 over n squared plus n. So now we're going to do the sum, as n goes from 3 to infinity, of 1 over, so n squared minus n is the same thing as saying n times n minus 1. So this is partial fractions. So this will be sum as n goes from 3 to infinity, something over n plus something over n minus 1. We're going to use cover-up method. So when n equals 0, cover up 1 over n times n minus 1. So cover up the n. So it would be n equals 0. So 1 over 0 minus 1 is negative 1. Cover up n minus 1. So that would be n equals 1. So plug that back in. Without it, it'd be 1 over 1. So this will be the sum as n goes from 3 to infinity of 1 over n minus 1 minus 1 over n. So this will be 1/2 minus 1/3 plus 1/3 minus 1/4, and so on. This will cancel with something. 1/3 and negative 1/3 will cancel, and this will just be 1/2. The sum as n goes from 3 to infinity of 1 over n times n plus 1. So this is n squared plus n. So this is this bound right here. So again, it's partial fractions. This will be the sum as n goes from 3 to infinity. Something over n plus something over n plus 1. Cover up n equals 0. So that would be 1 over 0 plus 1. So that would be 1. Cover up n plus 1. So this would be n equals negative 1. Plug that back in, and you get 1 over negative 1, which is negative 1. So this can be rewritten as 1 over n minus 1 over n plus 1 in parentheses. So this will be 1/3 minus 1/4 plus 1/4 minus 1/5, and so on. This will cancel with something here, and all those will cancel, and 1/4 and negative 1/4 will cancel. So this will be 1/3. So we have 1/3 is less than the sum, as n goes from 3 to infinity, of 1 over n squared is less than what we got here is 1/2. And the sum as n goes from 1 to infinity of 1 over n squared is 1 plus 1 over 2 squared, which is 1/4, plus the sum as n goes from 3 to infinity of 1 over n squared. That means that the sum as n goes from 1 to infinity of 1 over n squared. So this is 5/4. So this will be less than, so I'm going to rewrite this 5/4 plus sum as n goes from 3 to infinity of 1 over n squared. So this is between 5/4 plus 1/2 and 1/3 plus 5/4. So let's get a common denominator. So this would be over 12. This would be 4 times 1 plus 5 times 3 less than the sum. N goes from 1 to infinity, 1 over n squared, less than, multiply this by 3, multiply this by 6. So I'll just do it for just to show more work. So this will be 5 times 3 is 15 plus 6 over 12. And this will be 5 times 3 is 15 plus 4 is 19 over 12. Sum as n goes from 1 to infinity, 1 over n squared is less than 21 over 12. So if I take the midpoint, that would be the sum as n goes from 1 to infinity, 1 over n squared, is approximately equal to, the 12 on the denominator will stay the same, and the average between 19 and 21 is just 20. And we can simplify that to be 10 over 6, which is 5/3. And that is